Good morning, everybody. I remember the very first time that I made a machine learning algorithm. It was called Nearest Neighbors, and in my mathematics class, we were trying to take images of digits anywhere from 0 to 9 and use the computer to predict which digit it was. The cool thing about this algorithm is that it really used a simple method, and even though I was the one who implemented it, I remember at the end being completely shocked by the magic witchcraft that happened when it was able to predict these numbers with such accuracy. Today I'm going to be talking about classification trees, which is one of the tools used in machine learning. Classification trees are really nice and they have a lot of benefits, such as the way that they make these decisions is really similar to the way that we as humans can do it. It's also really intuitive to see what's going on behind the scenes. Today, as I talk about this, I'm going to talk about how these trees are built and then some of the applications that are used. Let's go ahead and get started. So as any machine learning algorithm starts, we have to start with something, well, the machine to learn. In this case, look at this example. We have these various fruits and various measurements on them. The measurements, such as weight, color, and length, are called our predictor variables. And those are the ones that in the future we want to use to predict the response variable, which in this case is what fruit it is. Now, the way that these trees start is that they take all the data and split them into two groups. Right here in step 2, you can see that it has to use one of the predictor variables. So in this case, it uses length and puts all the variables or all of the data points that have a length greater than 11 on the left and everything that's less than 11 on the right. Now, the way that it splits this is using a mathematical measure called the Gini index. And what it does is it tries to keep variables of the same type in the same category. In this case, it did really well because it kept all the bananas on the left and kept all the apples and oranges also together. If it would have on something else, such as color, it wouldn't have done as well because it would have put one of the apples, the yellow apple, with the bananas, splitting the apples from each other. Now the algorithm continues to make these splits, trying to make the groups as pure as possible. As you can see right here in step 3, it split again on this right group based on the color this time, putting the oranges in one group and the apples in another group. Now, in real life, though, the data might not always be this clean cut. In the end, you might get some groups that are still mixed and that you can't really split any better. Now, in this case, when we get to an end group, we say, okay, we weren't able to make it as pure as we wanted it to be, but if we ever get to this point again, the majority of these data points are apples. So we will assume that the data is an apple. The real magic happens when then we're able to take a new data point. So for example, in this 4th step, we come up with this green fruit that we don't know what it is. We get measurements such as its weight, color, and length, and then we started at the top of the decision tree right here, answer each question, and eventually come to the conclusion that it must be an apple based on our previous knowledge. Now, I know this is kind of a silly example, but the cool thing about this algorithm is that it's able to extend to other machine learning methods, some called random forest and XGBoost, which take the same idea and either add some twists or some complexity to make it more robust. I know that this also is an example of kind of silly classifying fruit, but there's a lot of cool things that you can do with decision trees, such as identifying cancerous tumor cells, identifying spam in your inbox, or even trying to predict which customer or which product on your website a customer might buy. So whatever your methods may be, go out there and learn about classification trees, make discoveries, and let these algorithms do all the heavy lifting for you.